Hi, this is Google Kickstart question story of seasons, and this is the third question from round F. You are given the variable D, which represents the number of days of the warm season, and the variable N, which represents the number of kinds of vegetable seeds. The variable X is the maximum number of seeds you can plant each day, and these seeds can be of different kinds. In this example we have D equal 5, so here we have 5 days, and N equal 4, so we have 4 kinds, and we have X equal 1, and that means we can plant at max 1 seed on each day. Now for N equal 4 we have 4 types or 4 kinds. Every kind has 3 values. Q is the quantity of this kind of seed. L is the number of days it needs to mature. V is the value of each matured plant. For example, for this kind we have Q equal 1, and that means that we have 1 seed of this kind, and it takes 2 days for the seeds to mature, which is the value L, and the value V, we gain 3 after selling this plant. Now we need to return the maximum total amount of profit. For example, if we plant this seed at day 1, it takes 4 days to mature. So this is day 1, and this is day 2, day 3, day 4, and at day 5 we can sell it and gain 5, value 5. Now if we want to plant this seed, day 1 is already occupied by this, so we used it to plant this seed, and X equal 1, so we cannot plant more seeds on this day. So for this seed we will plant it at day 2, and it takes 3 days to grow. So this is day 1, this is day 2, this is day 3, and we sell it at day 5, and by selling it we gain the value 10. Now if we plant this seed, so day 1 we plant, it's full, day 2 is also occupied, we cannot plant more seed, so we can plant it on this day, day 3, and it takes 2 days to grow. So this is day 1 and this is day 2, and we sell it at day 5, and we gain 3. Now for this seed, this is occupied, this is occupied, this is occupied, we can plant it on this day 4. It takes 2 days to grow. This is day 1, this is day 2, but this is the last day of the season, so we cannot sell this seed, and this means that our answer will be 18, the sum of this value, and this is the maximum number we can obtain. So how can we solve this problem? What we need to do is we need to sort the seeds based on the value, and so this is the first seed, and this is the second, this is the third, and this is the last one. We sort them based on the value, and what we need to do is to try to plant the seeds with the highest value, because this guarantees that we will gain more money, and we will try to plant it as late as possible in order to leave some earlier days for other seeds. So we start with the maximum value 10, and we have one seed. This type takes 3 days to grow, so what we will do, 5 minus 3 equal 2, and this means from this day to the left we need to find free slots that we can use to plant our seeds. Day 2 is free, we can plant one seed on this day, so we will plant this seed on day 2, and by doing that we will gain 10. After selling this plant. And again, day 2 means that this is the latest day we can plant this seed and sell it at the end, because if we plant it after this day, like this day, and it takes 3 days, this is 1, 2, 3, this means that we cannot sell it. This is why we need to search on from day 2 and moving to the left side. So we started with the largest value. The next largest value is 5. It takes 4 days for this seed to grow, and so we have 5 minus 5 is the last day, minus 4 equal 1. And so on this day we need to search for 3 days in order to plant this seed. Day 1 is not used yet, so we will plant this seed on day 1, and it will take 4 days. At the end we will sell it and gain 5, so we'll add 5 to our answer. The next greater value is 3, and it takes 2 days to grow, so 5 minus 2 equal 3, and this means that we have to look from day 3 to the left side to find the first day we can plant this seed. So we have one seed and day 3 is not used, so we will plant this seed on day 3, and at the end we will gain 3, so we'll add 3 to our answer. The next greater one is 2, so 5 minus 2 equal 3. We need to look from day 3 to the left and find any available or free days. So this is already used, this is already used, this is already used. This means that we cannot plant this seed, and this will be our final answer. 10 plus 5 plus 3 equal 18. Let's take another example here. So we have D equal 5, N equal 3, and X equal 4. So we will start from the largest value, 10. This seed takes 3 days to grow or to mature, so we have 5 minus 3 equal 2. This means that we need to search from this day to the left, and find if there are 3 days. The first day free, we will use it to plant this seed. So day 2, we can plant up to 4 seeds. Initially it's 0, then we can plant these 2 seeds on day 2, and by doing that we will gain 2 seeds multiplied by the value 10 equal 20. Then the next value is 5, and it takes 4 days for this seed to grow. So 5 minus 4 equal 1, and this means that from day 1 to left, we need to search for the first available day. Day 1 we did not plant any seeds on this day, so we'll plant the 2 seeds on day 1, and by doing this we will gain 2 multiply by the value 5 equal 10. Then we have the value 3. Takes 2 days for this type of seeds to grow, so 5 minus 2 equal 3. This means that on this day, going to the left, we need to search for the first available days to plant 5 seeds. In day 3 we can plant up to 4 seeds, so we'll plant 4 seeds this day, and we will gain 4 multiplied by the value 3 equal 12. And so we planted 4 seeds, and this day is full now. We keep looking for empty slots, so day 2 we planted 2 seeds, we can plant more 2, but there is only 1 remaining, so we will plant it at this day, and we will gain another 1 plus 3 equal 3, and our final answer will be 20 plus 10 plus 12 plus 3 is equal 45. Now notice that we need to do this search efficiently, because the number of days in the question is very large, is 10 to the power 12, and so we cannot create an array or doing linear search for the 3 days. And to do that efficiently, we will create a set, and in this set we will store the 3 day segments. For example, initially we will have on the set the segment 1 to 5, and this means that from day 1 to day 5 they are free, and we are going as we are going to fill the days, we will split this set, and for the edges also we need to store in a dictionary that maps the day to how many seed already planted on that day, and if the number of seeds planted on that day become X, we need to remove that day from this set. So this is the set of pairs that will contain the 3 days. So initially it will have this pair 1 5, and this means that day 1 up to day 5 are free or available, and this is the dictionary where we will store the planted seeds. For example, if in day 1 we planted one seed, so 1 will map to 1, and by this we can remember if any day has some planted seed. And this is the last allowed day variable, and we can calculate this by d minus l. So let's see in this example how can we do that. As we said, we need to sort the seeds based on the value, and we start with the largest value 10, and it takes 3 days for this seed to grow, and that means the last allowed day is 5, which is the day or the next day, minus 3 equal 2. So this is the latest day we can plant this seed, and we will do binary search using the lower bound method. We will look for 2 plus 1 and 0, and we will do the upper bound or the value next to our value. Then we will do minus minus iteration to get the set we need. You can do it in a different way, but this should work. So we will search for 2 plus 1 and 0, which is 3 and 0, and the method will or the binary search will return a pointer to the end of the set, and we do minus 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 minus. So this is iterator, and our iterator will be minus minus iterator, and the pointer will become to this set, and we need to access this set 1 and 5. This means that there are available days from 1 to 5, and our last allowed day is 2. This means that the day is in the middle of this set, so we need to remove this set from the available days, and we will insert 2 new set, 1 to 2, which is the border or the edge, and from 3 to 5. And for 2, we use it to plant 2 seeds. So in our dictionary we will store that 2 plant has 2 seeds planted. So these will be our available days, and this is our dictionary. And because we planted 2 seeds of this type, and we add our answer 2 multiplied by the value 10. And then we need to access the next greater value. It is this one, 5, and this takes 4 days to grow, and this means the last allowed day is 5 minus 4 equal 1. And in our set we will do binary search for 1 plus 1 to 0, and this will return us the iterator next to what we need. So this will return a pointer to this one, and minus minus this pointer, we will have this set. So this set contains 2 days, 1 and 2, and the last our last day is 1. So we will use 1 to plant 2 seeds, and so in addition to 2 has 2 seeds. Now 1 has also 2 seeds, and we keep the sets as is because this is not full yet. We need to add to our answer 2 seeds planted multiplied by the value 5. Then we need to process the last value, and this takes 2 days to grow. So 5 minus 2 equal 3. This is the last allowed day to plant this type of seeds. So 3, we need to search for sets. 3 plus 1, 4, 0, and we will do lower bound or binary search to get the next set of what we need. So 4, 0, this is 1, this is 3, and 4 will be the end of the available day set, and minus minus will bring the pointer to this set. Now this set contains days 3 to 5, and our last allowed day is 3. So we will use day 3 to plant 4 seeds, because here in the dictionary 3 has no we did not use it to plant any seed before, so we can plant 4 seeds on this day. 4 plus the value 3, and day 3 will have 4 seeds, but we don't need to add it to the dictionary because the day is full. What we will do, we will delete 3 from the sets, the available days, and so this sets we will delete it from the available days, and we will insert another set, which is a 3 plus 1, 4, 5, because 3 is full. Now we have one remaining seed, and what we need to do is do iteration minus minus. So we move the pointer from here to this set, and the last value is 2, day 2, and day 2 we have 2 days or 2 seeds planted, so we can use it to plant the remaining seed, and we update this value to 3, and we add to our answer 1 plus 3, and this will be our final answer. Alright, let's look into the implementation. As we said, first of all we need to sort the kinds based on the value, and this is the dictionary that will store the value or the number of seeds planted on any day if these planted seeds are less than X. And here we iterate over all the kinds. So the first one will be the one with the greatest value, because we already sorted it. Then as we mentioned, we need to calculate the last allowed day, which is D minus L, and then we do binary search for this value, last allowed plus 1 and 0, and this is the next set of the set that we need, and this is why here we do previous or LP minus minus. Now, first of all, if the last allowed day is greater than the set we found, we set the last allowed day to the second, or the greater value in the set. For example, if the last allowed day is 5 and our set is 1, 2, 3, this means that the last available day is not 5, it's 3. So we set the last allowed day to the second value, which is this one, 3. Then we need to check all the possible cases. Here we need to check if the last allowed day equal to the first element on the set. Then we calculate how many seeds we can plant on this day, and it's possible that this day is completely free. It's possible that Q is less than the available number of seeds we can plant on this day. So this is why we need to S equal to min of x minus day planted seed on this day, and the Q. And so S is the number of seeds we can plant on this day, and we decrement the Q value, the number of seeds available, by S, because we will plant this number on this number of seeds on this day, and we add the planted seeds value to our answer, which is S multiplied by V. Now we need to check if the planted seed plus like S plus the already planted seed on this day, if it's equal X or not. Now if it's not equal X, we will update the dictionary value. So for example, if we have here 1 and 3, and we said the last allowed day is the first one, and let's say the diction X equal 4, and D of 4 or of 1 equal 1, and we need to plant S equal 2. So here 2 plus 1 equal 3, which is less than 4, and which is this case. So we just update this value, because it will be 3. We still can plant one seed on this day. Otherwise we need to remove this set and insert a new set. For example, if we need to, so this is 1, and we need to plant 3 seeds. So 3 plus 1 is 4, which equal to X. So this day is full, and we need to remove this one from this set. And so we will remove this set and insert a new one. Now the one inserted is the last allowed day plus 1, and the LP second, which is the max or the other edge on this set. So if we have here 1 and 3, we will delete this, and we need to insert a new one, 2 plus 3, 2 and 3. Now it's possible that the set is 1, 1, and so if we delete this one, if we need to insert a new set, 1 plus 1 is 2, so we cannot insert 2 and 1, because this should be less than this. This is why with every, before every insertion we check this value is less than or equal to this value. Now we handle the case where the last day equal to the first element on the set. Now if it's not the first element, we need to first of all use the last allowed day on the set and see how many seeds we can plant using the last allowed day, and we modify our answer. Now if this last allowed day managed to planted all the seeds or Q becomes 0, it means that we need to check two conditions. Now if the last day plus S equal to the max value, again we need to remove this day from the set and split it. It will be last plus 1 to the second and first to last day minus 1, and of course we do the checking before any insertion. Now if Q is not 0, that means that we need to update the value on this day. So day planted seed last day plus equal X, because here if it's equal X we need to erase the set and split it into two parts, but here we need also to split it into two parts, but one of the edge we need to update the value of the last allowed day, and last allowed day should be included in one of the sets. So here you see last allowed day to the second, but here we have last allowed day plus 1 because this day is full, but here it's still less than X, so we can use it. Now if Q is not 0, that means that we are not done yet, and what we need to do is to see for the remaining days on the set how many seeds we can plant it, and this we need to take first the last day we used here and calculate all the remaining 3 days, and that equal to last allowed day minus 1 minus LP first multiplied by the X maximum, and always the edges first or second there might be some planted seed on that day, so we exclude this day from this calculation, and then we add how many planted seed on or how many free seed on this day, and at the end we get the max allowed seed remaining in this set. If the max allowed is less than or equal to Q, this means that we need to use everything on this set, and we need to just remove the set until the last allowed day. So from a last allowed day to the first we will remove that part, and we need to keep only the last allowed day plus 1 up to the second. And of course we will update our answer by the max allowed seed multiplied by the value. Now if this set is not enough to make Q 0, first of all we need to see how many days required for this Q. So days equal Q divided by X, and we update the answer by this value. Now again, if q is 0 using these 3 full days, we need to split the set into two parts. The first part is so let's, for example, we have here 1 to 6, and we use the value 2 to 4, so we need to split it to 1 1 and 5 6. So this is what we are doing here. Now if q is not 0, this means that we are not done yet, and that means, for example, if we have set 1 to 7 and we use this 3 to 6, now this was not enough to plant all the seed, so we need to use the 2, and that means we have to first remove this set, and we'll have 1 2 and 7 7. Note that here the 2 has part of x, because if it's fully free day, it will be included in this part. So here q will become 0, and we split this set into two parts.